increasing, decreasing, and constant. That's what we're going to look at here. But first I want to, so increasing and decreasing can be, I found that it's a little confusing for some at first. So I'd just like to draw some dummy graphs up here and go over what increasing looks like on a graph and what decreasing looks like on a graph. So first, just say we have this graph here. And some of you, this is going to, you already got it, and that's fine. I want to make sure that we're all on the same page here. So when you look at this graph, and here's the x-axis and the y-axis. This is just my dummy graph right now. What is this graph doing? Is it increasing or is it decreasing? And how do you know if it's increasing or decreasing? Because it's depending on which way you look at it, right? That's where a lot of people get confused. So you want to read a graph like you read a book. You read a book left to right. You read a book left to right, just like this. We're going to read this graph just like that. So you start on the left over here and you move to the right. And what's the graph doing? If you're starting here and you're going to the right, this graph is increasing. So that means it's an increasing. That means it's increasing. You can think of it as a little man walking right here, and he's going that direction, and he's walking left to right, and as he's walking he's going uphill. So that means that this is the increasing graph. Alright, what about this one? If I have Alright, you read it left to right. So as your man's walking, he goes from left to right too. He's walking downhill or decreasing. And then if you have this last graph, that chalk's not working very well. This here, you have your man, he's walking left to right still. He's walking at a constant speed, constant pace. So this is constant. Alright, so those are our three: increasing, decreasing, and constant. Just think of it as a book. You read it left to right. Some of you might be asking, well, what is this? What happens when you have a vertical line and your man is walking on it? Well, he's just falling to his death. So that doesn't mean anything to us, all right? So we're not going to see this. We're not going to have that right now. So don't need to worry about that. Okay, let's look at a few examples, because reading the graph is usually the easier part. Usually, and you got to learn how to use the notation too. And so that's sometimes the biggest mistake that I see a lot of times. So let's say determine increasing, decreasing, and constant. And here's part A. So we're going to have our X and Y axis, X axis, Y. And I'm going to draw a couple points on here, and so follow along with me best you can. We're going to go out 4 this way and up 1. So on the test I won't give you, these points won't be given, but since it's kind of hard to read and I'm a terrible drawer, I'm just going to give them to you here. 4, 1. Nope. -4, 1. Then we're going to have -2, 4, -2, comma 4, and then 1, 4, and 3, 1. So those are my points, and I'm going to connect them like this. All right, so I need to look at this graph, read it left to right, and determine what's increasing, decreasing, or constant. So I really don't care how you start it. You can start from the furthest left and just go. But I tend to just do increasing first. So I'm looking at this left to right, and let's see, I'm starting over here. Here's my increasing portion. So what is my smallest value here that's in, where does it start increasing? And something I failed to go over just now is when we write what's increasing and decreasing, we use the x-intercept values. So or not the x-intercept, excuse me. We use the x values here to label increasing, decreasing, constant. So it's very similar to domain. And in fact, you are writing the domain here, but you're just breaking the domain now into 3 different sections, into increasing, decreasing, and constant. So it's still the domain, but we just write it a little differently, and I'll get to the part that's different. So here, the smallest value is -infinity over here. And so, and it's increasing up to this point, which is -2. So remember, only x values. So it starts at -infinity and it goes to -2. Now, do I include or not include that point? This point right here. So we don't include it. That's the big difference in increasing, decreasing versus domain. We always use parentheses in increasing and decreasing in constant. Always use them. And in an example or two, I'll show you why. It'll make a little more sense then. Just know, domain, you can use brackets. Increasing, decreasing, you always use parentheses. It's always x values. All right? Now let's, well, there's still another portion that's increasing over here. So we said that this portion here was increasing, so we already have it. Now this portion over here is increasing also. It starts at x value of 3, and it goes to infinity. So union 3 to infinity. And remember, this just means and. It's increasing here and here. So that takes care of this portion and this portion. All right, let's go to decreasing. It's only decreasing, reading it left to right, in this portion here. So we need to figure out the x values that it's decreasing in. It starts at 1, x equals 1, and goes to x equals 3. 1, comma 3. And that's it. So we have this portion taken care of. Now here is our constant. All right, it's constant from x equals -2 to x equals 1. X -2 to 1. All right, let's look at another. Call this part B. And then another graph. All right, so just to make things easier, I'm going to say this is -3 and this is 4. You'll have the whole graph and you'll have to count yourself. It won't explicitly tell you what the numbers are, but just for the sake of what's going on here, I just need those there. So we have this, and we have this. Here's our y, right, so try to do increasing and decreasing and constant yourself here. Just pause the video and give it a try. So I'm going to start with increasing, just because, well, I like to. And if you want to do it differently, that's okay, just as long as you understand the concept and you can get the correct answer. So increasing, we're reading this left to right, we look and it's increasing from here to here. And we're looking at x values, so it starts increasing here at -3 and it stops here at 4. All right, so -3 comma 4. And do I use a parenthesis or a bracket? I use a parenthesis. Increasing and decreasing is always parentheses. And now decreasing, I can see that it's decreasing in 2 spots now. It's decreasing here and here. So the smallest value, if this goes to negative infinity and it decreases all the way to -3. So negative infinity to -3, and, or union, if I say union, it means and 4 to what value? Remember, we're looking at x values, that's positive infinity. 4 to infinity. All right, so there is increasing and decreasing. Now, let's get back to why we use parentheses everywhere. So, what I'm curious about is what happens here at that point and here at this point. Those 2 points are where the graph goes from decreasing to increasing and increasing to decreasing. So what exactly is happening at those points? Are they increasing or are they decreasing? Or do we know? So we don't know. So that's why we use parentheses everywhere, to not include those points, because those are the transition points. So what we call these are the relative min, and this is the relative max. All right, and the word relative is important here, because this graph technically goes to infinity. So this is the max. This goes to negative infinity. That's the min, all right? But we don't care about that because we just know those are going forever in a straight line. What we care about is the meat right here in the center of the graph, in this range where I drew. This is where the fun's happening. So we care about these terms and we care what's happening at those terms. So we don't include them in increasing and decreasing. We give them these relative max and min names. That indicates that it's turning or transitioning at those points. So that's something else you'll see. It has a relative min, a relative minimum, I'm just going to say min, at that point here. I didn't write y value the next. Let's just call this -5 and this one 7. So that point would be -3, -5 for the min. And then I have a relative max at 4, 7, and a relative max at 4, 7.